So to be able to complete our activity here with this data on a graphing calculator is going to involve a couple of extra steps. I'm going to give you the raw data for these 1,000 different babies that were born, but we can't import that data directly into the graphing calculator. And there's no way you want to type in those 1,000 numbers for obvious reasons. That would take, nobody's got time for that. So we're going to have to use some kind of other tool to be able to help us. If you're comfortable using Excel, or if you want to explore the R option for being able to do some of these summary statistics things, you totally should. But I'm going to show you how to do it in Statcrunch because that is the easily available option on your homework. So Statcrunch is available through your MyStatLab homework. So I went to the Statcrunch website through there. Again, usually on your homework, it'll prompt you to open the data in MyStatLab. Okay, and so you can upload a data set, and I have the data set saved in my downloads file. So I'm going to open that up and upload it. Okay, and from there, okay, there's a couple of different things that I can do. So the first thing that I asked you to do is to make a side-by-side box plot of habit and weight. And so to do that, you can go into graph and then box plot. Okay. You're going to check the Y variable. So that's your numeric variable. In this case, we want weight. Okay. That's the birth weight of the babies. And we want it grouped by habit. So we want a separate box plot for each of the different smoking habits. And you can customize some of these other things if you want to make it prettier, but let's just go ahead and compute. Okay. And you can see here that it's created a very nice side-by-side box plot, right? I guess there was one in there that didn't have the smoking status specified, but we can see that for the non-smokers and the smokers, we've got these sort of two side-by-side box plots. And having these side-by-side allow us to compare things like the median, right? Or measures of the middle. Seems like, you know, the middle of this one might be a little bit higher than the middle of this one, but it's hard to tell from this graph, right? And we can also look at spread, right? So, okay, the spread here seems to be a little bit farther spread apart in terms of the range. The highest minus the lowest is a little bit farther than this one. But, you know, if we just look at sort of the whiskers, they're seeming pretty comparable. So a nice visualization is a nice way to sort of compare the centers and the spreads of the two different groups as a nice sort of preliminary start. The second thing it asks us to do is to calculate the mean weight of each of the different habit groups. And again, I'm going to recommend that you use the tools here in Statcrunch to help you do that. So if you go to stat and then summary statistics on columns, okay, then we can go through and select weight as your Y variable. And again, we're going to want to go through and group this by habit. Okay. If you hit compute, it's going to work out all of these different test statistics for you. The things that might be particularly useful here are the mean. That's your sample mean. So that could be X1 bar and X2 bar. I'm sorry, that's so small on your screen, I'm sure. And then this would be S1 and S2, right? Or sorry, the standard deviation S1 and S2. So we might use those in some of our calculations. So let me just pull up my graphing calculator again. All right, so here's my graphing calculator. So a couple of different things. So the first thing I want to do is, I know there's two separate groups and the data here is not paired, right? We have two very independent groups. We have a group of smokers that really have no relationship to our group of non-smokers. So we know we've got two independent samples. We might have that from there, we have to decide whether or not we're going to pool the variances together or whether we're going to keep them separate. Do we want to assume that the sigmas, the standard deviations, are the same or not? And so we have a little test to be able to do that. Remember, we take the two variances and divide them by each other, or we take the standard deviations and take them squared and divide them by each other. If they give us some number between 1/2 and 2, we're going to pool them together. And if they're not between 1/2 and 2, then we don't pool. And, you know, even if I just look at the box plots, oh, they're gone away. I'm not going to pull them back up. But remember on the box plots, they didn't seem like the spread seemed pretty similar between the two. So my guess is we're going to end up pooling them, but let's find out. So I'm going to take these numbers from Statcrunch and just plug them into my calculator. So if I do 1.5186806 and then square it. So that's my standard deviation from the first group divided by 1.3861798 and then square it. Okay, that's going to give me an error. Perfect. Love it. Why is that giving me an error? 1.51868. Oh, because there's 2 decimal places. 6 squared divided by 1.3861798 squared. This should work better. Okay, there we go. So the ratio there is 1.200. Okay. I also could have taken the 2 variances and divided by them by each other. So I could have done 2.306 divided by 1.921. That should give you the same answer. Okay. So that's my number. And remember we said if that number is between 1/2 and 2, then that means the standard deviations are close enough that we can assume they're the same. And we're going to use our pooled variance. Okay. So that's what we're going to do in this case. So in order to get to our 2 independent t-test where we're going to pool the variances, you're going to go to stat. You're going to go to stats and then over to tests. And then you want 2 sample t-tests. That's number 4 on your list. Okay. Then from there, we're not going to use it from the data because nobody wants to enter in 1,000 numbers of data onto your calculator. So we're going to do it from the statistics. And you're going to use the statistics that we got here from Statcrunch. Okay. So, so for X1 bar, we're going to have the first group be the non-smokers. So the mean for that group was 7.1442726. Good. The standard deviation from that group is 1.5186806. Oops, I keep doing that with the 0. I think it's because I'm on my phone calculator, which is not as easy to work with here. 806. There we go. And the number in that first group was 873. The mean X2 bar was 1.92149444. The standard deviation was 1.386178. Oh, 798. The number in that group was 126. Okay, I'm going to decide to do a 2-tailed test here. So for this hypothesis test, I'm going to test the null that the 2 means, the mean birth weight between the 2 groups is exactly the same against the alternative that they're different from each other. And I'm going to do a 2-tailed test. So I'm going to leave the not equal to selected. And then they've asked me whether or not I want to pool the variances. And in this case, I'm going to say, yes, I do want to pool the variances. And I did that because when I worked out the ratio of the 2 variances, right, I got some number between 1/2 and 2. Okay. And so I'm ready to calculate. Okay. And it's going to spit out all kinds of different things. Now this is slightly different numbers than I remembered. All right, I figured out why I got slightly different numbers. It's because I entered these numbers in wrong. So I did my X1 bar okay, I did my S1 okay, I did N1 okay, but for X2 bar, I should have put in 6.828. Maybe you caught me earlier and you were like, what are you doing, Emily? But alas. Okay, so let's make sure we get this in right. So this should be 6.8287302. That's better. And then my standard deviation is still correct there. And I'm still going to do this, a 2-tailed test, and I'm still going to not Still going to pool the variances. Okay. This is more like what I remember. Good. Okay, so I've got my test statistic is 2.203, okay? And that follows a t-distribution with 997 degrees of freedom, and that corresponds to a p-value of 0.02. If you were going to go through and test this with 95% confidence or an alpha of 0.05, that would mean that the p-value is smaller than my alpha. So I would reject the null hypothesis. I reject the hypothesis that the two means are the same. And I have significant evidence here to suggest the difference between the two means, that the mean birth weight is different between the two groups. And that shouldn't surprise you. Remember, let's just pull up the box plot again really quick. The weight and group by habit. Okay. You know, that shouldn't surprise you to know that, you know, one of them is slightly bigger than the other. What I do want to be careful of here is I do have statistical evidence here to say that the birth weight is different between the two groups, and I can definitely say that. What I want to sort of hesitate to say is it doesn't necessarily mean that the smoking is what caused it. And this is because this is an observational study, right? We didn't assign the people into the two groups, the smoking treatment or a not smoking treatment. That would be highly unethical. We just sort of observed their habits and then looked at sort of what's going on. And so, yes, definitely on average, the birth weight is smaller among the smoking group than the non-smoking group, but there could be some other factors at play, right? That could be diet, that could be exercise, that could be access to healthcare and healthcare information. I'm not totally sure, right? Could be extra variables here that we're not sort of looking at. So I am going to conclude there's significant evidence of a difference in the birth weights between the smoking and the non-smoking group. What I'm not going to say is that I know for sure that the smoking is what caused it. Okay. So that sort of allows you to go through and conduct the hypothesis test and get the p-value and everything that you needed. If you wanted to also get a confidence interval, right? So this is showing us that there's sort of significant evidence of what's going on, right? At the 95% level of confidence. If you wanted to sort of specify, well, how different are they in terms of their weight? That's when we would go through and get a confidence interval. And so in order to do that, you're going to do stat tests. And then rather than, oops, my one sample t-test or my two sample t-test, I'm going to do a two sample t-interval. It should keep my stats from earlier. And so I can use that and make sure I'm pooling and press calculate. And there, that's going to give me a confidence interval there for the difference. So in terms of the difference in mean birth weights between the mums who are smokers and non-smokers, that difference is between 0.03 of a pound and 0.6 of a pound approximately. I'm not a doctor. I don't know whether that is a big enough difference to make a practical difference for the baby and its health over time, or the mother. But we could present that data to them and show them that, yeah, there actually is a significant difference here between the two. So that's how we would go through and do this on a graphing calculator. Again, if you have another tool that you like better, you might use R to help get some of those summary statistics. You can watch my other video on that, or if you prefer to use Excel, you're welcome to do that. But I showed you how to do Statcrunch since it's available through your homework.